Yes, hello, Mr. Prahlad. Welcome on YourPedia platform, and let's start your heat transfer snap for your final DRDO interview.
Thank you, sir.
So, Prahlad, what is heat transfer?
So heat transfer is a scientific study of interaction of two bodies at thermal interaction between two bodies.
So what is required for the transfer of heat?
A temperature difference is required. For certain kinds of transmission, we require a material medium as well.
I suppose there are two bodies having different energies.
Okay.
Maybe one having much higher energy as compared to the another one.
Okay.
So from where, in which direction heat is going to transfer? Heat transfer is going to take place.
So if the higher energy body is at higher temperature, then
it is not required all the times. A body which is having higher energy will have higher temperature also. Is it required?
No, it's not required.
So I'm not giving you the temperature. I'm just giving you what one is having higher energy, another one is having lower energy. So in which direction heat transfer is going to take place?
So for heat transfer, we require the temperature difference. So heat transfer depends.
For example, the lower energy body is having higher temperature.
Okay.
And the higher energy body is having lower temperature. Then
naturally it would be energy would flow from higher temperature body to lower temperature body.
Means lower energy body to the higher energy body.
Yes.
Prahlad, why heat transfer is an irreversible process?
Because it is restricted by the second law of thermodynamics, and also there are dissipative effects like frictional effects, viscous effects, which are irreversible effects.
So, okay, when work is converting into heat, obviously due to some kind of friction, that is considered as a kind of irreversible process. But I'm not giving you that case ki work is converting into heat. I'm just giving you, for example, let's take a case, heat is transferring from one side of a wall to the another side.
Okay.
And in steady state, for example, if we will consider the wall is in steady state, so whatever heat is going to enter from one side, the same is going to leave from the another side.
Yes, sir.
But then also that transfer of heat is a irreversible process. Why?
Because it's not a quasi-static process, and usually reversible processes are quasi-static process. So
where are the irreversibility in that process?
In this process, each and every layer undergoes a change in its state. As a result, there is a temperature gradient that is formed. So that cannot be reversed without any external agents.
Prahlad, what are fins? For what purpose we use fins?
Fins are extended surfaces that are usually used to accelerate the convection heat transfer.
Okay, so have you seen such kind of fins on some transformer?
Yes, sir.
So how we provide the fins, like on maybe kind of like on the vertical fins we provide, or some kind of horizontal fins we provide?
So I have seen vertical fins on transformers.
Vertical fins?
Yes.
Achha, why vertical? Why not horizontal?
Because vertical fins help in natural convection. Convection.
Natural convection heat transfer will be more in that case.
Yes.
Can you tell me more about that? How you can say that natural convection heat transfer is more in vertical fins?
Because hot air rises up. So if we have a vertical fin, then the density difference between the top layer and bottom layer will create a buoyant force, which will lead to circulation of air. But in flat surface, there is no difference in buoyancy due to the flatness. So the convention is not as proper in as compared to the
Okay,
vertical
Prahlad, let's take a case. For example, we are having a square plate.
square plate.
Okay. Square plate we are having,
Hmm.
and one side of the plate is insulated.
Okay.
For example, the plate is at some constant temperature. Okay, and we are transferring heat from the plate.
Okay.
Or we are having two different cases. One, we can keep the plate vertically.
Hmm.
Another, we can keep the plate horizontally. Okay, one side of the plate is insulated. When we are placing it horizontally, the insulated side we are keeping downward. So heat is going to convect from the top surface. Okay.
Hmm.
So in which case, what do you feel heat transfer will be more and why?
Heat transfer will be more for the horizontal plate with insulation down, because it is in direct contact with the thermal reservoir. And for the vertical case, but it will be lower than the vertical case, as I already told, because of the density difference. It's accelerated for vertical plate case.
So fluid flow velocity will be higher in which case?
Vertical case, sir.
Vertical case. But heat
Yes,
transfer
vertical.
you are saying is more in horizontal.
No. Heat transfer rate also will be higher in vertical plate. But for the horizontal plate with insulation down and insulation up case, insulation down case will have higher heat transfer rate than insulation on top. That's what I
No,
was telling.
we are comparing only the horizontal plate insulating surface down with the vertical plate.
Okay, in that case, vertical plate
Don't
will
take
have.
that case of insulation up.
Okay.
So vertical plate, you are saying heat transfer will be more.
Yes, sir.
But don't you feel like when we are taking a horizontal plate, every time the fresh air, the low temperature air is going to come in contact with the surface?
Yes, sir.
No such film formation is going to take place. But in case of vertical plate, there must be some film over the surface, and which is going to restrict the heat transfer. If there is some film is forming over the surface, some kind of boundary layer is going to grow, and that is going to restrict the heat transfer as compared to the horizontal plate.
Yes, sir. So I only consider the natural convention for both the plates. I did not consider any external agents by that of air.
So boundary layer formation takes place in forced convection only. In free convection, there will be no boundary layer formation.
For flat plate, yes, sir. Sorry.
There will be boundary layer formation in free convection or not?
Yes, sir. Only for this vertical plate.
For horizontal plate, it will not be there.
Yes, sir.
What is Biot number, Prahlad, and what is the significance of Biot number?
Biot number is the ratio of conductive resistance to that of convective resistance. So Biot number gives us to perform, if the Biot number is less than 0.1, then we can assume the lumped mass system. So it shows that the temperature that is in the body at the center will be same throughout the body, and hence we can perform lumped mass analysis on that system.
What do you understand by lumped mass?
Lumped mass is any body which is having approximately uniform temperature throughout the body.
What is the difference between a thermal boundary layer and a hydrodynamic boundary layer, Prahlad?
Thermal boundary layer is formed by virtue of the temperature variation, but for velocity, hydrodynamic boundary layer is formed by virtue of the velocity profile.
So how the thermal boundary layer formation, thermal boundary is going to change? Suppose, for example, if we'll take a case of forced convection, okay, some fluid is flowing over the flat plate. So, TBL thickness increases as we move in the flow direction.
Yes, sir.
And same with the HPL, hydrodynamic boundary layer.
Yes, sir.
So, can you tell me the reason why actually HPL and TBL grows in the direction of flow?
For hydrodynamic boundary layer, we have the no slip condition. So as a result, the layer which is at the contact with the surface will be having zero velocity, and the ambient velocity would be much higher than the zero velocity. So as a result, we can see higher growing thermal boundary layer. In case of thermal boundary layer also, due to the no slip condition, the layer in contact with the surface will have the ambient surface temperature, and which is different from the ambient temperature. So as the fluid moves, we can see this thermal boundary layer thickness also increases in line with the ambient temperature.
For the flow over flat plate, Prahlad, can you give me some kind of energy equation and momentum equation?
Yes, sir. Should I write it down?
Yes, just write.
Okay. So momentum equation is mu dou square u by dou x dou y square minus dou p by dou x is equal to rho into u dou u by dou x plus v dou u by dou y. This is in the x direction. And for energy equation, we have rho Cp into u dou t by dou x plus v dou t by dou y is equal to k into dou square t by dou x square plus dou square t by dou y square plus mu into phi.
Just show me the equation and just tell me the equation, the part of okay, it is not visible. No, it is not visible. Prahlad, okay, it's fine. I think you mentioned it correctly. One term you mentioned, mu del u by del y square. So what that term is representing?
Mu phi.
Yes.
So that is the viscous dissipative effects.
What do you understand by viscous heat dissipation?
Viscous heat dissipation by virtue of viscosity. That is, different layers of fluid will have different temperature, and this will lead to a thermal stress that is developing, which will lead to an energy dissipation. So that term is usually neglected for simple purposes, and it is significant only for high viscous fluids as well as for high pressure flows like aircraft, etc.
High velocity.
High velocity flows.
Okay. So what is the significance of Prandtl number in heat transfer?
So Prandtl number gives us a relation between this thermal boundary layer and the hydrodynamic boundary layer, since it is a ratio of the momentum diffusivity to that of the thermal diffusivity.
How much is the Prandtl number for water?
It is around 10, means 1.7 to 13.7, that range.
You know, for evaluating the kind of heat transfer in case of pipes, okay, or ducts, we consider two different cases, like constant volt temperature and constant heat flux.
Yes, sir.
Can you give me some practical cases where we can go with these particular cases, like constant heat flux and constant volt temperature?
So for uniform heating cases, for example, heating in a thermal coil, in all those cases, we can consider uniform flux. And for constant temperature, this boiling condensation, that is constant temperature case. In boilers and all, we maintain at constant temperature.
What are gray bodies, gray surface?
Sir, I'm not very sure.
I hope somewhere in radiation part you studied gray body.
Yes, sir. So they are not perfectly black bodies. So the exact definition, I'm not very sure, sir.
You know, in entire studying, like if you go through that chapter, you will find we generally assume a surface as a diffuse and gray surface. So why we assume, you know, a surface as a diffuse and gray? What is the significance of gray surface?
Sir, I'm not much
Okay.
thorough about that.
Okay. You heard about Planck's law?
Yes, sir.
Just tell me more about that.
The quantum Planck's law.
Mm-hmm.
The
Planck's law of thermal radiation.
Thermal radiation, it shows that the emissive power is proportional to inversely proportional to the wavelength of radiation.
No, that is
So-
Wein's displacement law. Both are same. Planck's law and Wein's displacement law. But there is a
No.
difference.
There's a difference, sir. Wein's displacement law is lambda t is equal to constant. Planck's law is EB is equal to C1 by lambda raised to 5 into C2 e raised to lambda minus 1, like that.
Okay.
Planck's law is the
Lambertian surface.
Huh?
Can you tell me something about Lambertian surface? What are Lambertian surface?
I didn't get you, sir.
You heard about Lambert cosine law?
I know, sir.
You have not heard about that.
No.
You heard about Lambertian surface. There are some surface known as Lambertian surface.
Okay.
Okay.
Prahlad,
what is thermal diffusivity and what is the significance of that in heat transfer?
Thermal
diffusivity.
Thermal diffusivity is represented by the letter alpha. So that shows that gives us information about the capacity of a body to transmit thermal energy through it. So if a body is having high thermal conductivity, it can transmit energy faster. So it may have large thermal diffusivity.
So if you will compare liquid and gases, which one will have more thermal diffusivity? A gas, maybe air or water?
Sir, I think gases may have higher thermal diffusivity.
But you mentioned if a substance which will have more conductivity, it will have more diffusivity.
Yes, sir. It's also K by rho Cp. K by rho Cp. Cp for water is fluids is liquid is so much higher than that.
Heat picked by the gases will be more as compared to water.
Yes, specific heat for liquid is higher than that for gas.
So heat transfer, like suppose you are passing at a same rate some air and some water. So in which case heat transfer will be more, heat lost will be more, air or water?
Water only, sir.
Water only. Good.
Water only.
Then what is the significance of that? You mentioned gases are having more thermal diffusivity, and you are right. Gases thermal diffusivity is higher. So what do you mean by that? The heat transfer is more in water?
So water can absorb more heat because since specific heat is more, water do absorb heat, but in the case of gases, the absorption of heat is less, but they can conduct more.
The penetration of the heat will be higher.
Higher for, yes.
So what one word you can add, Prahlad, they are going to acquire the solid surface temperature more quickly. They will very quickly heat it up.
Okay, sir.
If some air is passing over a surface, they will very quickly acquire the hot surface or hot bath temperature as compared to liquids.
Okay.
Fine. So my last question to you, Prahlad.
Yes, sir.
Okay, let me provide you the feedback. Okay, and again you can join me because I think 7:45 time we have fixed with another student.
Okay, sir.
So मैं आपको अभी feedback देता हूँ प्रहलाद. Prahlad, your understanding is looking fine. I started with some of the basic question, some questions related to convection heat transfer. I started with heat transfer in a transformer, and yes, very correctly you mentioned, highlighted. We provide some vertical fins because natural convection will be higher in those vertical fins because very quickly air will be able to move over the surface. Okay, but if you are providing some horizontal fins, then obviously the air flow will be difficult. Okay, and heat transfer will be lesser. But if you will take a case of plate, if one side is if both the sides are convecting heat, then the heat transfer will be more in vertical plate. Prahlad, because both the sides are going to convect the heat
Hmm.
and a kind of equal heat transfer will be there from both sides. But if you're
Okay.
taking only heat transfer from the one side,
Hmm.
one side, insulated and only heat is convecting from one surface, one side. And if you're
Hmm.
keeping that side up, so in that case, heat transfer will be more in the horizontal plate.
Okay.
Why? Because obviously the movement of the air will be higher in vertical plate. But due to boundary layer formation, a thin layer is going to form over the surface, and that thin layer will be at some particular temperature.
Hmm.
And when air is moving over the surface, every time its temperature is increasing, so the temperature difference is actually going to decrease.
Hmm.
But in case of horizontal plate, every time the fresh air is going to come in contact.
Hmm.
There are two things actually. The movement of the air will be higher in vertical plate, but movement will be lesser in horizontal plate. But what is the second thing? In horizontal
The
plate,
film
every time
formation.
the fresh air,
Okay.
the low temperature air is going to come in contact with the plate. So due to interrupted boundary layer formation, due to very thin, or what you can say, there will be no boundary layer formation actually. In
Hmm.
that horizontal plate, there will be no boundary layer formation. Due to that, the heat transfer will be more in the horizontal plate. Fine, Prahlad?
Yes, sir. Yes, sir.
Gray surfaces are the surface bodies which are having constant spectral emissivity. So if the spectral emissivity is not a function of lambda, okay, spectral emissivity is independent of wavelength, okay, that particular surface is known as a gray surface. So gray surface, the pattern, the variation of EB with the lambda will be very much similar to the black body.
Hmm.
Planck's law tells us about that key the spectral emissive power of a black body is a function of lambda and T.
Hmm.
As you are going to increase the lambda, the spectral emissive power is going to increase. It will reach to some maximum and then it will start decreasing. Okay, that is Planck's law. And further, if you take some kind of higher temperature, as you are going to increase the temperature of the body, that
Hmm.
particular curve, the EB versus lambda curve, that curve will shift towards the left. Okay,
Hmm.
that's why that is known as Wing's displacement law. So as you are going to increase the temperature, the curve will shift towards left. Means the wavelength corresponding to maximum spectral emissive power will start decreasing, because high temperature body they emit radiations. Most of the radiations are of shorter wavelength. Okay, so what you can get idea you can get from that, Prahlad, gray bodies, their pattern, their variation of EB lambda with lambda is very similar to the black body. Okay, their absorptivity emissivity is less than 1.
Hmm.
Okay, so they are much closer to the real surface. Real surface, they are having some emissivity less than 1. Blackboard
Hmm.
is an ideal surface, ideal absorber, which is having emissivity 1.
One.
So it is very difficult to analyze real surface. So that's why we consider some gray surface. The pattern will be very much similar to the black body, and the curve will be much closer to the real surface, real body. So that's why we will get more approximate close results. Fine, that is the significance of gray body, gray surface.
Okay.
I think then I asked you about Biot number and this TBL, HBL concept. I think thermal diffusivity is clear to you, Prahlad, now, na?
Yes, sir.
So thermal diffusivity is the ability of a fluid to acquire the hot surface temperature more quickly. More is the thermal diffusivity, more is the Fourier number. More is the Fourier number means the faster, the quicker will be the heat transfer, conduction. The temperature penetration will be much higher in that body. Prahlad.
Yes, sir.
So air, they are going to very quickly acquire the temperature. Heat transfer will not be more in air. Heat transfer will be more in liquids.
Liquid.
But they are going to acquire the solid surface temperature more quickly. Fine, Prahlad. So your
Yes.
way of delivery is looking fine, Prahlad. You are looking confident. Okay, your understanding is also looking fine. So मेरे को as such कोई major issue नहीं लगा. And I feel if you practice more and more, definitely you will get through this. Your understanding is looking good, Prahlad. You are applying your mind. You are trying actually. So it's good, Prahlad. Keep preparing. Anything if you want to ask, you can ask now.
Uh, so this would be the level of question that would be asked in the interview, right,
No,
sir?
further they can go into more detail, Prahlad. They are very, very expert in their area. Okay. But in general, let me tell you,
Hmm.
the student, who are having some basic fundamental understanding, okay, of all the subjects which generally we study at our graduate level. So that is more than sufficient. But they're not going to ask you advanced level question. They're going to ask you the basic level question only. They're going to check your fundamental concept and how you are approaching, how you are trying actually each and every question. Okay. So you need not to worry about advanced level question. They are not going to ask you, but yes, they can go into more fundamental details. Even, in these kind of sessions, there is a limitation. We cannot go beyond 10-15 minutes. But in your final interview, the interview can go beyond 50 minutes also. Okay. That kind of, exposure also you will get through full marks.
Okay.
So in those things, they can further ask you to derive such kind of equation. I think I asked you about momentum and energy balance equation.
Yes.
They can ask you to stand in front of board and drive that equation. Use all suitable assumptions. And on what assumptions we can get that. Are you getting it, Parla?
Yes.
So those kind of things further they can ask you. But the level of question will be in that manner only. You need not to worry. Practice more and more.
Okay.
Fine? Okay. Parla, good luck. Keep preparing.
Thank you, sir.